Hi everyone. This is a first for me, so thank you everyone for joining. This is my first Twitch stream. I'm very, very excited to be on the Microsoft Developer channel, so thank you to all the team who are setting up all of the cloud advocates running their stuff on this channel. It's really exciting. So hopefully you can hear me okay, in case anyone wants to let me know we have any issues. I have the chat in front of me. I also have Cassie. Oh, awesome. Thank you for letting me know it sounds okay. I also have Cassie, one of my colleagues, who is, she's going to be kind of moderating some of the questions as well. So if there's anything that you're considering asking, if I am sort of heads deep in whatever I'm doing in the code, Cassie's going to help out as well. So feel free to say hi to Cassie. So yeah, let's get started. I wanted to tell you a story basically about some of the things that I've been working on. I've taken some of the stuff that I do for my work and kind of combined it with some of the stuff I do in my personal life. And I hope that it can be quite interesting. It's quite a long story. So we're going to talk about sentiment analysis, and I'm going to talk a bit about some of these new techniques that I've found and novel scenarios that I've applied them to, but also looking at what I've done in the past and how I've actually built on it now, be that in the tooling, be that in the algorithms, etc. So yeah, let's just jump straight in. She says, there we go. Okay, let me transport you back. We're going to go back to September 2013, which now in 2020, we are 7 years ago at this point. I was at university. I'd just come back actually from working at Microsoft for a year. I was an intern at Microsoft, and I came back and I was like, okay, what am I going to do to apply all the amazing stuff that I learned about machine learning at Microsoft for a year? And so I went to like my lecturer person about my research, and I said, I've got an idea. This is what I'm going to do. And first things first, if anyone on here is from the UK, there's a lot of UK references, but I will explain everything, so don't worry. But does anyone recognise any of these people? That they are very UK based, but they were all on a specific show. Can anyone like guess what show it was? I was quite a fan at the time, but I'll be honest, I don't really watch it anymore. They were all singers, so that might start to give it away a little bit. But let me jump in. So something no one knows, that's fine. What I'm going to introduce you to is the X Factor. Yes, Dean, the X Factor. Okay, so these were some of the contestants in the X Factor 2013. Oh my goodness, makes me feel older. And the person in the middle, his name's James Arthur. He actually won the competition. He's still a singer today. I think he's on my Spotify playlist somewhere. I was a big fan of the lady in the top right corner. Her name was Ella Henderson. She's not really released anything recently, but she was really, really cool. She was kind of a favourite to win, and it was a bit crazy because she didn't, and that was something that I found in my research. And then we also have a gentleman in the bottom left called Ryland Clark. He is on UK daytime TV and everyone loves him. He's the best. So he actually came out of the X Factor. The X Factor is a singing show. So if you're really, really good at singing, I think we have things like it all over the world. But yeah, super exciting. But you get to know the people. And so one of the things I said was I'm going to do some research basically on the Twitterati, I called it. So I was able to extract X Factor data, and then also Twitter data about it at the time. And then I named it this. My supervisor must have been like, why do I always get the ones that do the crazy stuff and not just the normal kind of like computer science theory? But this, I thought it was super exciting. So the Twitterati actually has a definition. It's users of Twitter, especially those who post frequently and have a large number of followers. So think your Barack Obamas, your Katy Perrys, your Justin Biebers, etc. And it's so interesting to see actually that a lot of social media influencers are incredibly popular, but they also get a lot of attention on social media. And to be able to kind of like analyze whether people are favoriting a certain person over another in some senses, especially on shows like The X Factor, was something I wanted to investigate. Could I do it with the data that I was able to get publicly? So my statement, my hypothesis was, given Twitter data, can I predict the outcome of The X Factor? And fast forward, so we were September 2013, fast forward, we're in June 2014. June's decent weather in the UK, so it was probably nice and sunny, and I was graduating. In fact, it was a really hot day when I graduated. And one of the things that I kind of looked back on was like, oh my goodness, at the start that question seemed so trivial, but this was what I actually did in the 9 months. It was endless experiments, loads of different tests, loads of different models I applied. I extracted different data sets. I compared loads of different ranking scenarios. This stuff was intense. Like, this wasn't, I think everyone thought, oh, the X Factor project. But actually, there was so much underlying theory, but all this theory can still be applied. But I can hear you even just through the chat. Well, did it work or not? So when I had a chance to present this in person to people, people would be looking at me being like, well, did you guess it or not? Did you predict the outcome of the X Factor? And what I did was I tried to rank each contestant per week. And actually, surprisingly, it did a pretty good job. So I created a sentiment analysis classifier. So is it positive? Is it negative, the sentiment? And then I decided how I was going to rank the different contestants. So would I just look at the positive data? Would I minus all positive tweets from negative tweets, or vice versa? And so many other different things. Well, it was really, really cool. I was able to actually correctly rank. So when there was less than 6 contestants per week, so at 5, 4, 3, and then it's the final, I was able to rank them in order. So that was pretty cool. Like, I was quite surprised. This is impressive. I actually used really what looks like now quite basic algorithms. My favorite algorithm, or the best performing one, was the support vector machine. That was just from scikit-learn, which is a machine learning Python package. It's nothing special. It's not a neural network. It's not deep learning. It's not all the fancy stuff that we see now. It was just a very, very basic classification algorithm. So it's interesting to see it still did so well. One of the things that made it do well was I both trained my models and obviously applied the inference on domain-specific data. If I'd just taken random data from Twitter, it was likely not to do as well. So a good theory on that was if you mentioned music in X Factor, that was just neutral because everything is about, well, yeah, everything's sort of about the music and the people. But if you mentioned music in a normal tweet, music is likely to be positively inclined. Hopefully people are talking about music, they like music, it's good for us, etc. So this was some of the stuff why training on domain-specific data was so important. There was some things, and this was more looking back because I didn't really dig into it too much when I was submitting all of this for my final grade almost, surprisingly. But on some of the reflection pieces, there was some improvements. So the way I actually applied my algorithm, because it was a supervised machine learning algorithm. So supervised machine learning is where you pass it data, so the tweet, one single tweet, 10 million tweets, etc. And the supervised element is you also have a label, so you have the answer. So in this case, I would pass it one X Factor tweet and I would say it was positive, and I'd pass it another one and I'd say it was negative. Now, it seems like it's a super manual approach, but one of the things I did, which I read from a research paper at the time, was emoji assumption. So basically, if a tweet had an emoji on it, because a tweet is quite short, you can probably in most cases guess that emoji relates to the whole tweet. So if it was a smiley face or a laughing face or like sort of I don't know, big grin face, or if it was like a crying face or an angry face, then that would be like a bad tweet in some senses. So I was like, okay, that makes like perfect sense, and I can, you know, do this to so many tweets with a simple regular expression. So at the time I did that, but I mean, it's probably flagging up now. You're probably thinking like, well, there's a massive downfall there. Sarcasm. I'm naturally quite sarcastic, and so like if someone puts on like a laughing face, maybe it's actually a really negative tweet, or maybe the way we read it doesn't necessarily explain the way the person who writes it feels about it. So that was a big downfall, and something that I wanted to work on. I also was able to classify tweets, so I was able to say, hey, like this is I think this is a positive tweet and this is a negative tweet, and then analyze them and rank them. But one of the things that I wasn't able to provide was the context of why. So yes, this tweet is positive, or this tweet is really negative as well, some of them. But why? Like, what was it about it? Was it the singer? Was it the song choice? Was it what they were wearing? Was it the sort of sad story that they put on at the start sometimes of each contestant? That context of why was missing. It was just like, this person's extremely positive, and unfortunately some people were really, really negative, and it was, you know, it was really, really terrible to see. And the final one was manual approach. All of those different like numbers and charts that I had in that like big document that I wrote up, everything was run like super ad hoc. Like I would run it from like my command line using my Python scripts on my own machine. I mean, like I have the old laptop actually down here. That thing doesn't turn on anymore. Like I destroyed that machine. So it's so like strange now to think about that was how I did it then. Like, and I'll show you how I would do it different now. But also I would literally have like an Excel in the background, like noting down all the numbers super manually. And it's just not something we need to do now. So it's interesting to see how far we've got with tooling. Anyway, that was the past. Let me fast forward. We're a little bit closer to where we are, but you'll probably notice we're still sort of 7 months away. Well, in September 2019, one of my colleagues, Ari, if you are into natural language processing and like analysing text, follow Ari. Ari is a super expert in this space. And we went and our team did this Microsoft Ignite the tour, and we went to many, many places across the planet, and we delivered some really, really cool content. And so a few of us worked on the AI and machine learning path. Ari built a really cool session. You can get it from the link just down there at the bottom. And he introduced me and also other members of our team to a new approach for natural language processing, and he applied it and used it within his scenario. And I just thought it was super impressive. He made it look very easy to use. We'll talk about that in a bit. And I was like, oh my goodness, I can see so many uses for this. So what is it? Well, it's called aspect-based sentiment analysis. So instead of having that just, this is a tweet and it is positive, it actually splits it out. So it says what was positive. So if we take the example of the first sentence, loved the sweater but hated the pants. Well, loved the sweater is great. So the sweater is what we call the aspect, and the positive green circle around it is what we call the opinion. And it's also great. You'll see the second sentence is all positive, but then the third sentence, the shoes are bad, but the blouse is perfect. So that's interesting to see as well, because if you think about TripAdvisor sort of reviews, or reviews on your favourite retailer, you never just write like a completely positive review. You always say like, we loved this and we loved this, but we kind of weren't sure about this, and you know, this wasn't great. You really want to split out as a retailer, as a customer, as the business owner, really understand what people are saying in reviews and actually analyze what the the aspects are that you could improve on. So we could see here that the retailer might go, well, someone really didn't like those shoes, like we should dig into all of the reviews about those shoes and then see if there's something like specific, like, I don't know, the heel breaks off or the soles wear really quickly, and then hopefully we can fix it for future customers. So I saw this as the asking for the what. So the what is it positive or is it negative, but also asking for the why, and that was the piece that I was missing when I was looking at the X factor. So how does aspect-based sentiment analysis work? I highly recommend, this is actually created in a framework called NLP Architect, and it's created by Intel. They have some really, really cool documentation on it. I highly recommend, like, if you're going to use it, like, go and have a proper good read through it. This diagram is actually from their documentation. But I just wanted to show you like how it breaks down. This is actually a form of machine learning called unsupervised machine learning. So the idea is I don't have to anymore pass it information about this tweet is positive and this tweet is negative, or this sentence is positive and this sentence is negative. This approach will actually do it for you because it's unsupervised learning, so there's no label. So one of the things to, let me just move this chat out of the way so I can see it. There we go. A couple of things to think about is we have our training stage in the blue at the top, and then we have our inference stage, or inference is such a strange word. Basically the stage where you have a model and you want to give it new data and see the outcome. So in the training data phase, we just pass it like a CSV of loads of comma-separated text sentences. It then passes it into its training method. It does some pre-processing. It tidies up the data. That is a huge part of any approach to data science. Especially Twitter data, it's a mess when you get it out of the API. So it's really, really interesting to see that this does some pre-processing for you. It does pre-processing that it specifically needs to apply. So you might need to do some more, but I don't think I really did anything too specific to it. And it still was able to work for many of the scenarios. It then does something called parsing. Parsing is thinking about the sentence and the structure. So this starts to get into like psychology, and the how we build language models sort of thing, but it literally breaks it down into how different words affect others in a sentence. So is something a noun, an adjective? If something is running faster, then faster is applied to the verb running, and that should like amplify it or something like that. Parsers act in all different ways, so there's obviously a lot of specifics, but it was really interesting to see they use that quite early up front to understand the sentence that they're learning from. Then they extract some terms, so we're going to see some of them, which is quite exciting because they do a really good job of outputting an understandable format. But a candidate term, in this case, I see as an aspect, something that is basically an item that comes up that has some kind of description about it that is influencing the sentence to be positive or negative. And then what it actually does is it has an opinion lexicon. So a lexicon, I see it as quite like a fancy word for a list or a group of words that you've got that have got something assigned to them. So in this case, an opinion lexicon has like a word like bad, and it has a opinion like negative applied to it. And so then it might have a word like beautiful, and it'll have an opinion like positive attached to it. Now what this does is it has that built-in lexicon, but it re-ranks it depending on your data. So you know how I said how it seemed very important to have domain-specific data for the music example? Well, this would be really interesting here because it might then downgrade something like music and it say actually this is neutral. It's not something that should be deemed super positive in this data set. Cool. And then what it comes out with is it then comes out with an opinion lexicon, so that lexicon of words that has all of it re-ranked depending on your subject. and then an aspect lexicon. So the aspects are all of the key words it's basically picked out, was what I could see. And I'll show you, and it'll make much more sense. And then finally, we go into the stage once we've trained our model. We then pass it new data along with the two outputs in the model. It does some of the same approach, and then it passes our classified data. So it basically says, here's a new tweet. Tell me what's going on in it, basically. Where are the aspects, the items, the things, and what are the sentiments that are applied to it? Cool, so that was a little bit of theory, and it can get quite deep. So yeah, highly recommend going to look at the documentation. So they have a really, really cool NLP Architect site, and it kind of just talks you through all the different steps that it goes through, which is always really, really cool to see. Okay, so let's fast forward again to literally last month. So last month I started working again on this problem. So I was quite impressed by the approach that Ari had taken. And one of the things that I wanted to do was I actually wanted to say, okay, like I wonder if I can apply it to a different scenario. Ooh, sorry, we have frozen there. Okay. So I wanted to know if we can apply it to a different scenario, but first what I want to show you is how Ari did it, because all of this stuff is actually available on GitHub. You can take it away and run this code, and then you'll also see that I use this code as like scaffolding basically to then create my own project. So let me show you some of what we built. So I'm using Microsoft Azure. This kind of relates to the tooling comment that I made about one of the improvements. Azure Machine Learning in Microsoft Azure is a tool that can help you with all of the stuff that I had to do manually. I don't have to run any experiments on my laptop anymore, so my nice Surface Book will not get destroyed. It is a much more powerful machine than I had before. But also things like keeping track of all those different experiments. They're all actually just available inside the portal, whereas before, like, I was having to like physically note it all down and do all the comparisons between it and all of that kind of stuff. They built some really cool tooling to just help you monitor your experiments and so much more, like send them to production, put them into containers. Like, I am not really like that I don't know a lot about containers. I know like the bare minimum to kind of be a little bit dangerous, but I wouldn't say I would want to put anything to production. But it's so great to see that this is built in here, so I can test it and then work with someone that is an expert in containers if I was to send something to production. So it's a really impressive tool. And so I'm going to show you basically how I used it. So I created this workspace. You literally just go to Microsoft Azure, create a new resource, type in machine learning. You then give it some basic information like a name, a resource group, a location. So all the usual stuff. But what I want to show you is not just how you create it, because that's nice and easy. There's stuff about actually using it. So you'll notice here it's telling me to upgrade. We have an enterprise edition, and then we have a like a free sort of version in some senses. Now the free version allows you to just use, if you're into data science, things like Jupyter notebooks in Python, RStudio using R. You can run experiments. What you pay for is the compute that you use, and we'll see that in a minute. But the upgrade to enterprise also offers things like automated machine learning, so different services that we've built into Azure Machine Learning, and also the Azure Machine Learning Designer. So it's kind of adding up those two things. In this case, I was just using notebooks and code, so I actually don't need to upgrade to enterprise. However, for a lot of my projects, I use things like the Designer or automated machine learning. So then I would click upgrade here, and it just upgrades it to an enterprise. I also click on something called the Azure Machine Learning Studio. I see the pieces in the Azure portal as like almost like the infrastructure setup in some senses. So thinking about like access control, thinking about all the different things that are available, like do we need to lock it so people don't delete it, etc. Do we need to track some metrics from it? all of the stuff you get with all like other Azure services. So I see this as like the setup part. But where I actually work when I'm using Azure Machine Learning is in the studio. So if I click on the studio here, it opens up my studio where I can see things that I've run recently, compute that I've got available to me, and all different services that I can use. So I want to like jump straight in and just show you, because it's kind of I love the tool, I love the service, but it is exciting to just see like how I actually used it more than like here's every different feature. So if I click on compute, one of the things that I created was something called a compute instance, which I see, and you'll notice from the name in here, I see it as like my development machine basically. So you can just run everything on your laptop. So I could run Jupyter on my local machine. I could type Python, I could create Python code and run it locally, or I can still actually connect to what I'll show you, the Azure Machine Learning SDK from my local machine. However, I quite like the fact that I can just get up and running with the latest version of Python with, you know, really popular Python packages already installed, Jupyter already set up, or Jupyter Lab or RStudio, etc. So it's a really nice place to have like a vanilla development machine, nothing else on there that's going to like get affected, you know, the multiple different versions of Python that you have going on. So I basically created this. It's just a standard developer size machine. This is not like fancy GPU compute, this is just me working. So I then click on the Jupyter link, and what it will do is it'll open up the web browser with Jupyter running. If you're new to machine learning or data science, or just don't use this type of tooling, Jupyter notebooks are really, really popular in the data science space. They're a REPL approach, it's called, so read, evaluate, print, loop, and that means you can basically just easily write a tiny piece of code, run it, and see the output straight underneath it. So this is just like a folder structure, nice and easy. But if I open one of my notebooks, this is what it looks like. So I have some code cells. I can also add in different graphics and stuff like this. So again, if you go to aka.ms AIML40 repo, you can just pick up all of these exact same notebooks and run them. So feel free to grab them. So this is the ABSA stuff, the aspect-based sentiment analysis stuff that Ari created for Ignite the tool. So if we see, we can kind of like run through some of the notebooks, and what it will do is it will run an experiment. So let me tell you a little about what's going on. One thing to note is we're using the Azure Machine Learning SDK, so you'll see all of the Azure Machine Learning imports here. So the Azure Machine Learning SDK allows you to very easily connect to the service in the cloud and do loads of great things around tracking experiments, running experiments on remote compute. You'll also notice I imported some popular things like Spacey, the NLP Architect. So the model, the ABSA model, the aspect-based sentiment analysis model, is by NLP Architect by Intel, but that actually depends on Spacey also being available. And Spacey is a really, really cool library we'll see at the bottom that allows us to highlight all of those things in like green and red. And it also does their pre-processing, I believe, for it. So if I just run that, it will tell me I've got hopefully the latest version of the Azure ML SDK. I'm going to set up a few variables here, just things like what is my compute name, what is my experiment name, etc. And then the next 3 steps I'm going to take is I'm going to create a workspace or connect to a workspace, in this case, in my Azure Machine Learning service. I'm going to create or connect to some compute, so that's remote compute sitting in the cloud that I can push my experiment code to. And then I can also set up storage. So I can say, hey, like I don't want these big like CSV files full of tweets or you know, clothing text or something on my machine. I actually want them up in the cloud. And then also they do something really fancy where they actually mount the storage onto the compute in the cloud. So the ability to access that data is so quick, and that makes it much more efficient. So what you'll notice is we can use the Azure ML SDK to call our workspace from basically the configuration that we've got set up. So there's a config file, you just put in like your subscription ID, your username, etc., the resource group. And we can see that I'm using my ABSA workspace, and that is in West Europe, so that's the data center that it's sitting in. I also then can either create or attach to my compute. So if I run that, one thing that we'll see then is it says, hey, like if I have a compute cluster with the name, I think it's ABSA test, then just use it. Or, so in this case it is, or then if not, create compute, and you can give it lots of information about like what type of compute you want it to use. Fun fact, low priority is an option, so the ability to basically say, hey, like it isn't paramount that my experiment runs really, really quickly. It can run all night if it needs to, but if I want to, I can use low priority machines. So they're like a fraction of the cost, and so your machine learning algorithm, even if it runs for a long time to train, it can save you so much money. So I highly recommend putting that low priority tag on there. And then I mentioned the data store. I'm going to just connect to the default data store. Let me show you where that is. So if I go to Azure, you'll notice that it sets up like a strange named storage account here. If we click on that, and then we click on containers, and then we can see in here, there's loads of like snapshots of basically when I submit experiments, but also if we go into the blob storage, this is the default store that it is calling off to from my Jupyter Notebook. And inside you'll see I've got loads of different data sets that I've been using, and I can just call them really easily from this blob storage. So it's pretty neat because it's all kind of built in, and I can just do simple commands like get default data store for it to know where to go. Next up, what we're going to do is we're going to do something called creating an experiment. So we create an experiment. Experiment I like to think of, it's almost like a folder. I think of it as like a project or a topic. So we're going to do one here. So it's like ABSA, so aspect-based sentiment analysis. This is based on a very simple clothing data set for clothing reviews. And I'm going to keep all of them in one space, because if I make changes to this, I want to be able to see them all in the same place and compare them. Whereas if I move on to a different project, which we'll see in a minute, then I'll call the experiment something different. So in this case, we've called the experiment ABSA. Then I basically create and run something called an estimator. This is how do I want my machine learning experiment to run. So in this case, I tell it what the script is I want it to run. So it's a train.py script. That's available up here. We'll have a look at that in a second. I can tell it if it needs any environment variables. So remember, if we're putting this in compute in the cloud, we have to tell that compute exactly how it has to be set up. So things like pip packages, like the Spacey package and the NLP Architect package, we can say, hey, like you've got to make sure that that's on the machine so that my code will actually run. I'll be honest with you, like I set these things up and then reuse them like over and over again, or I like use the scaffolding of like a sample and then I add to them and tweak them. That's kind of the easiest way I find, because there is a lot of information in there. But once you dive in and you start getting to know the SDK a little bit better, it's really quite simple to make these small changes, but that do really powerful things. Let me show you the train.py script. So this is all like scaffolding code, I call it. The Azure Machine Learning SDK, it's not yet another deep learning framework or yet another algorithm we can use. It's actually something that's going to help us run and manage experiments and put compute over here and storage over here and make things happen. That's how I think of it. And so one of the nice things that I quite like about it is that you can literally run any Python library, any Python framework, any machine learning algorithm that you want to use. If it's something that you can run on your machine, it's something that you can run in the cloud and use all of this great service to actually kind of put around it. So let me show you the train.py file. Train.py is quite a classic name for a machine learning file, where training is, let me give you a training data set, let me build a model around it, and then test it normally at the bottom. So I'll do the same thing, I'll import anything that I need. So in this case, I needed a few extra things like the NLTK package. I needed scikit-learn for some of the metrics at the end. I bring in my NLP Architect framework, so from Intel. I set up any arguments that I want to pass it. So if I just called this Python train.py file, I can pass it a load of different arguments as well, if I want to. And then I can bring in the spacey dependency for the parser and the glove embeddings information that the NLP Architect model needs. So again, do check out all of the documentation for this, because it then all comes together quite nicely. Then what I'm able to do is actually pass it some training data. So in this case, it goes to that clothing data folder. So we're in the clothing data folder here, and it's grabbing, I believe it's this file here, or the small one, it might be the smaller one. And that is where all our training data is. So we can see that it's actually calling it as a relative, as a relative path, and that is going to be our training data set. Then one of the nice things about this, I was so impressed actually, is how simple it is to get it sort of into the right format. So you then use the train sentiment function, which you pass it any arguments. So do you have a threshold on anything? We can talk more about that in a bit. And then I pass it into this train variable. So that's basically saying, hey, like, how do you want me to set up the idea of running this thing? So this is like an object now, and it's kind of ready for us to pass it the data and tell it to go and learn. So then what we do is we can call that train object in some senses, tell it to run, we pass it our data set to learn, so in this case reviews of clothing data, and we tell it where to output the outputs. The outputs in this case are an opinion lexicon and an aspect lexicon. So when we looked at that the theory, that diagram, we said we had an opinion lexicon. So an opinion lexicon is a list of opinions with whether they are positive or negative next to them. And then an aspect lexicon, so all the different nouns or things that it's able to pick out of all of the data. And it says that a sentiment is applied to that aspect. So super interesting, but it comes out in two different files, so you can split these two things up, and then I saved them into an outputs folder here. Again, you can use all this code on GitHub, so the GitHub is all available here. All of the information and the notebooks are available, so please do go and check this out, because it does take a little bit of time to get your head around it, but I just want to give you an intro to how I applied it. An interesting thing that Ari put in, and I absolutely love it, is unsupervised methods tend to be very hard to measure with kind of classic metrics that you would use for supervised learning. And so one of the things he said that is, even though this was an unsupervised approach, it can be metriced with a small amount of labeled data. So we can give it a sample sentence and tell it where the aspects and the lexicons are. And then it can still make a decision as to whether it does a good job. So whenever we test in machine learning, we pass it a piece of information, we run it through the model, and then we basically say, okay, I see it's like a deck of cards almost. It's okay, what did you get? And then it's I got this. And then so if the human and the machine get the same thing, it's a big tick. If it's different and the model gets it wrong, then that is something that comes into, oh, it made a bit of an error there. So it will run through all of this, and then at the bottom what you'll notice is we bring in those metrics. So the F1 score, if you've heard of precision and recall, the F1 score is a really nice mix between the two. So sometimes precision is too specific for something you're doing, and you might have really, really high precision, but recall means that it actually doesn't really analyze anything unless it knows what the right answer is. So you have to have a good sort of balance between the two in most cases. So we'll use the F1 score here to rate it. And then what it will do, I absolutely love this, because this is my tracking of all the experiments that I run. This is where actually all the data comes from. So if you get the context of the run, which is the experiment that we'll run, you can actually log anything. So it's not like I have to log specific metrics or anything like that. I can literally log an aspect, a length of an aspect, an opinion lexicon, what is the length of the number of aspects it picks out, or what is the length of the opinion lexicon? Like, did it change? Did it drop some items? And then also that F1 weighted score. So you could do loads of different calculations here. Like, you could output every time it iterated or something like that, every time it ran a new piece, a new run through of your data or something like that. So it's super flexible, and I really, really like that. So when we actually then go to run it, so let's run this. And oh, another thing I really wanted to mention, and I'll probably do something another time on this, like the blog post or maybe a stream, now I'll get used to it, where you can actually tag your experiments, and I'll show you how useful this comes in a minute. Tagging experiments, I see it as literally adding labels to, like, what did you do different in this experiment from the previous one. And one of the things I always saw in my X Factor research was X Factor research, that's really funny, was actually that all of the different changes I had to make. So I had to try like different percentage ratios, different algorithms, different setups, different iteration numbers, different tuning, like, of the hyperparameters and stuff like that. But each time you make a change, you want to know what it was that made that difference. And so it's super interesting to see actually how did that change make a difference. And also you can review it really easily. Anyway, I'll put dataset.closing on this one, but for the next project it makes so much more sense. So if I run that, it will go ahead and submit my compute. It will tell it how it needs to run. It will send that train.py file. It will pick up my data as well, and it will basically just make it all happen. It's really, really cool. Like, it's kind of so simple. It's a bit worrying, but I can also then, because a lot of people get really worried about, oh, well, if it's running in the cloud, like, how do I know that, like, what's going on? Do I just send it off into the ether and I just have to wait until it decides it's finished? No. What you can do is you can actually see this run details.show option. And what this will do is it will tell you, like, how long it's been running, what is the run ID, and also be able to kind of like see what the start time was. And when this starts getting going, you'll see that it gives you all your logs as well, and you'll have like a drop down. In fact, let me do a bit of a blue pizza. You can see I've prepped this already. This will take quite a long time to run. I did think, I was like machine learning when streaming is hard. Like, you'd have to do like an hours and hours and hours of streaming to be like, oh, it finally ran, like, oh, it's running, or it's gone through one iteration. Like, machine learning sometimes takes a while. So what I've done is I've prepped kind of what it looks like, and we can always come back to that one. So this was a previous run that I did. We can see that it's completed. It took about 15 minutes to run, so it's not a huge one. But we can also see here, I prefer the driver log if it's here. Yeah, this one's better. So you can see every log file that it actually outputs. And we could, it's a good point, Brian, we could use that time to check the chat. So maybe we can try that in the future. Actually, I can be live running an experiment in some senses. That would be quite cool, but it would be really unnerving. Like, how many questions? 15 minutes worth, maybe. But anyway, the exciting thing here is it gives you all this information back, so you don't feel like you're disconnected from what's going on, even though it's not actually running on your machine, which is really, really cool to see. So that's always good. But where does this go, right? Because I said it like all logged everything. Well, if I go into experiments in the Azure Machine Learning Studio, and wait for it to load. How's my, oh yeah, my internet's doing okay. Then we go into the ABSA category here. So this is my experiment that I said, hey, assign this to the ABSA experiment. You'll see that I've actually run, and you'll see this one that we just submitted actually is queued here. And what you'll see is there's loads of great metrics about what's happening. So we can see all of the different ones that I ran, and I can take this ID and review it in the notebook. I can see how long it ran. I can see I submitted it, but if I was working in a team, then we could actually like see who was submitting what as well, and like keep track of that. Then we can also see basically anything I want to output as well can be added here. So tags, opinion or aspect lexicon numbers, etc. So it's a really nice view, and the graphs are really cool as well to be able to like actually analyze. You can edit these, so if I go on to, we don't want the opinion, the aspect one is interesting, but if I edit this one and instead of opinion lexicon, I want the F1 weighted score. So if I click save, what does this mean? This basically means that run 2 was my best performing output, because the F1 score was basically like 0.9. So 90% of the time I was like pretty confident that it got it right from my validation set. So yeah, really, really cool, because I can track it. So I can see whatever changes I made between 2, 3, and 4, unless they do like massive efficiencies or something like that on the runtime or the inference time, actually this one is the best metrics wise, and that's only based on my validation file. So I might want to do more around validation here. But that's a little bit about sort of a very, very basic example. This is all available, as I said, on GitHub. Please go there. Please go into these ABSA folders and look at the notebooks, etc. All of the code that we've just shown and exactly how to set it up is there, so you can run it. But the most exciting thing I want to show you is what I did next. So let me carry on with my story. I might run over a little bit here, but we'll be all right. So March 2020, right? I actually got a chance to speak at the Open Data Science community event for London, which was then moved online, so it was a big webinar, which was cool. I was really thankful to be invited. And so I said, well, actually, there's something that I've been wanting to work on. Ari, my teammate, he's done this cool stuff around aspect-based sentiment analysis, but there's also this other thing that I got really passionate about in like June 2019. And that was a TV program called Love Island. I'm pretty well known in our team for that at this point. It's a bit of a kind of an ongoing joke, but basically Love Island is another reality TV show. If I explain it, it sounds a bit mad, but basically a load of single people go to a beautiful villa in Mallorca, this one was. Yes, nice one, Sarah. I love Love Island too. And the fun fact is, it's a popularity contest. So it reminded me of the X Factor, right? It's the same kind of idea. And social media blows up, especially in the UK, so more locally, blows up around this. And so let me take that GIF off the screen, because that seems to affect my streaming rate. So one of the fun things here is that I actually then wrote up an article. So we, and if Dean is still on the stream, actually, one of the things on the stream was, Dean, who was on the stream a minute ago, he actually helped me really like loads with this in the summer. He's a bit of a fan himself as well. And he said, oh, like we got like a Logic app that was able to get loads and loads of tweets. So Azure Logic Apps is like a business logic type service. And what we were able to do was like scrape all of the tweets that had like hashtag Love Island in it, and then basically store them into a Cosmos DB. We recently got rid of the Cosmos DB and just put it into Azure Table Storage, because it's quite cheap, Azure Table Storage, and we weren't really using it as like a real-time thing at the time. I was analysing it and it was in more this kind of format, so I moved it to Table Storage. But one of the things we also did was actively watched the program and collected a load of data. So I created this this article basically. If you want to find it, go to the short link. I'll bring it up again in a minute. But basically it's here, and I had a chance to do all of these super interesting findings from the data. So it's the same thing, right? X Factor seems trivial until you start applying science to it, and actually it all totally makes sense. And it was exactly the same thing here. There was a load of hypotheses that I made. So in this case, if you're part of the first group of people to enter this Love Island villa, you're actually more likely to make a place. So first place, second place, etc. First place wins money, by the way, so that's always good. Most of the winners have come from the south of the UK, was another finding. So just from simple pie charts and data analysis, there was no machine learning here. This was not that. This was so basic, but it was so interesting. And then in that article at the top, you can actually get a link to an article I wrote of how exactly I did all of this, from gathering the data, using Azure Notebooks, what Python packages I used, etc. And I just explained it really is as basic as things like Wikipedia and Excel, and then some Python notebooks. So like, please go ahead and take a look at that. Cool. So yeah, that link there, we can probably put it in the chat. I can add that later. It's also on the end slide actually, so don't even worry about it. But two of the things I mentioned, so I didn't want to take exactly the same approach. I had all of these tweets about Love Island and I immediately said, just do what you did before. But that was like 7 years ago, and there's so many other things that we can try. Two of the improvements that I wanted to specifically apply was the context of why. So not just is it positive or is it negative, this tweet about this person on Love Island, but why? Like, what is it in the tweet that is positive and negative? Because one full tweet doesn't always actually anymore assume that everything is positive in one tweet or everything is negative. Even just very short comments can be both positive and negative. And then the very manual approach I took. I didn't want to be doing that. I wanted to be using tooling that was allowing me to experiment quickly, run in the cloud, all of that kind of stuff. And so I basically brought Love Island tweets together with the ABSA scaffolding code that Ari had built, and I kind of started to experiment. So let me go back to here. What you'll notice here, if I go to the ABSA Love Island notebook, is it pretty much looks exactly the same. So I took that basic code. Hey, am I back? I think I'm back. Can you guys hear me okay? Can we see me? It says I'm live again. Back, yes. Okay, awesome. Awesome, thank you, thank you, thank you. That's a little bit nerve-wracking, isn't it? But yeah, sorry about that. Hopefully it stays out for the next few minutes. Apologies, I'm not sure, it must have been my internet probably. Lovely. Cool, so we were running and connecting to my workspace. I have my compute ready and to go, which is cool, and my data store. So my data store, remember, has all my Love Island tweets in it. I then have my experiment name. So my experiment name this time is ABSA-Love Island. And we are then going to call this train-loveisland.py. So instead of the basic train.py file. So that sits up here. Again, it looks super similar. So if we continue down, the main things that I swapped out was basically the data set that it's taken in to train from. So I had a CSV file just like the reviews, so I was able to base it off that, which was really cool. That are comma separated, and I don't have to give it any labels, so unsupervised machine learning. I then use the train sentiment again. I get that opinion and aspect lexicon, so the opinions of everything, and then the aspects, the actual objects or items or nouns that are in the sentences. The unsupervised method, but we can metric it, which is so cool. Great work, Ari. And then at the bottom, we pass out the F1 score. So apart from, I literally edited out my data set. It was amazing, right? And then the main thing was then all the experiments I wanted to run. So if I create that estimator, and then here is where those tags really came into their element. I tried different types of data sets, and I'll show you the results for each. Different types of validation. Like I have actually I haven't shown you my validation file. Here, let me show you what the validation file actually looks like. Let me zoom in a little bit, there we go. This is what the validation file looks like. So how do I tell it what is right and what is wrong? So these are Love Island actual tweets. And what I could do is with every letter, this did take a while, I'll be honest. Every letter, what you'll notice is I said that Amy, ironically, who was in Love Island, not me, was one of the aspects that was coming through in my lexicon. And so I was like, oh, is this sentence, so I actually think Amy is all right. That's actually positive. So I added this Amy-positive aspect to it so that when it then gets evaluated whether it got it right or not, it should then be able to tell me if it got it right. So that's how you do it. You just add these simple little bits like Moira, she was another lady in it, or Amber, she was someone else in it. And I can then split up my sentence by that. So that's my validation file. And basically how many validation tests. So I want to keep adding to that, because kind of the more the better, because otherwise your percentages are all a bit over the place because it's only on a small set of data. And then iterations was 5 in this case. Those tags are not per row. Those tags are per experiment. So let me show you. Let me just show you. It's so good. Like, this was one of the things, like, I've been using this for so long. This was one of the things I hadn't really investigated before, and for this specific project, it just made it so simple. So what you'll see here is each experiment that I ran now, you can see the difference between them. So if we go further down, we can see the data set that I changed. So we can see with this experiment, ABSA ending in 2D7, I actually used just 1 week's worth of tweets to train it on to see whether it would evaluate well. I did another one where the data set was just about one contestant, so just about Amy, to see whether it learned just about her, and then I would just apply a different model to different contestants. And then you'll notice up here, this is when I only had like 3 validation sets, I think, down here, and so then I added in when I added more validation tests. And then the iterations is how many times it runs through your data set. So this, I upped it basically from like 2, I think was the default, to 5 times it would run through the data sets, and then 10 times. And so the key here is, what's the difference, I always like to think, between all these different experiments. So in this case, it's because I'm zoomed in. I don't think you can, oh no, I haven't got the F1 score on here. But basically what you'll see here is my aspect lexicon size was a bit all over the place, actually. I thought it was quite good when there was more aspects, but that's something I've got to investigate a little bit more. But the F1 score just continued to improve, really. The lowest being 75, 0.75, and then the second to last one getting up to 84. So that's a whole 10 percentage points difference, which is amazing, just about tweaking different things to do with your experiment. And then if I show you one of these, so I believe it was the one with 5 iterations. This one's my best one, so I'll show you that. When you run an experiment, it will basically show you all that information. So the F1 weighted score, what's going on with your lexicons, etc. It will tell you what compute it used, when it was run, if there's any models that are registered with it. But also, one of the great ones is in the outputs here. It will show you all those logs that you can get in the Jupyter notebook. But one of the things I really like about it is the outputs. So if I go and look at my opinion lexicon, this is what it looks like. This is when it started to make so much sense. So like, it would say things like abruptly. It's got that as being negative. So in the sense that it's looked through my data and it says, yeah, if they say abruptly, like, that is pretty bad probably. Whereas maybe abruptly in, I don't know, in a legal context or something like that is actually not that worrying. Do you know what I mean? Like, that's fine, that's just neutral. Or accurate is positive, or etc, etc, right? So all of these have been assigned with a lexicon, and if it sees it, it will apply it. And then also, if I go to my aspects, this was quite impressive, because this kind of explains exactly what it's doing. This has all of my tweets in it, basically. But what you'll notice is if I hover over just that bit there, it picks up all of the different aspects it's picked up. And one of the things I started to notice was Curtis, Ovi, Anna, Amy, Love Island, Maura, Amy again, Girl, Jordan, all of the aspects it picks up are actually the contestants. And I was like, whoa. Like, when it first did it, I was thinking, oh, maybe it'll pick up things like couples or, you know, Love Islands or something like that. It actually picks up the contestants. And so when we then start to see this applied, so let me show you the notebook. If we go to the bottom, when we then run this against some samples, we then start to see stuff like this. It doesn't do the perfect job, I'll be honest with you, okay? But like things like, I liked Amy at first, but she's getting annoying. It's not really got this bit. I would like a negative around annoying here. Should probably pick a better one, really. I really hope Amber and Michael win Love Island, so that's all positive. And then says, sorry, Curtis, who is another one, and that's then in negative. And I was just like, whoa, it took quite a while to get to here, and I think there's a lot more I need to do. Maybe that's adding more data. I have got a lot more data that I need to go through in my table storage. Annoying equals negative. Yeah, could I add it manually? That is so interesting. I wonder whether you could, because the actual opinion lexicon is just a CSV file, and it actually sits in here. I think it's in my temp folder. Outputs. Yeah. So opinion. So I could double check that opinion annoying or annoyingly is in here. That would be one thing I could do, and then make sure that it's tagged with negative. Or maybe it's the fact that it didn't come up, like, yeah, that could be one approach. I should do that. I'm going to note this one down, actually. I'm going to do that. I'm going to see whether I can edit it manually. But then editing it manually is also this other downside where it's like, I couldn't edit it manually for everything, and obviously the whole point of machine learning is that it's kind of flexible and it learns. But if there's something glaringly obvious like that, maybe that could be a really interesting one. Good question. Thank you so much. Cool. Basically, this is the output. So this is what ends up coming out of the model, and I've had a super interesting time just trying all these different approaches inside my experiments. But I definitely think I hit that improvement piece on the X Factor stuff. So I'm running it all in the cloud. I'm running it basically in inside this service where I can track everything. So I can track the changes in my lexicon, the changes in my F1 score, the changes in the time it takes to run. I mean, hey, look at this. The large data set took nearly an hour to run compared to the smaller data set, which actually did better on the validation tests, which only takes 20 minutes. So there's all these different things that you have to kind of compare to one another. Cool. So I'm going to wrap up. I had such a good fun just taking an idea, gathering my data, so my Love Island tweets, experimenting. I had a good couple of days, which was fabulous time to sit and code and just experiment through and hypothesize in my head why things were happening. I watched this keynote once at a machine learning conference, and they said, please don't let machine learning become alchemy, like a crazy chemistry experiment. It's something that should be kind of hypothesized and thought about. Why am I making these changes? Why does that make it better? Why does that make it worse? And I had a really good time doing that using the Azure Machine Learning Service. My next thing is to obviously build that model out and then possibly deploy it. It'd be quite cool if I could do it if Love Island runs again, whether you could apply it to it in real time and be able to see the ranking. So maybe I could bring in my idea from the X Factor and actually start to like live rank, or like even just slightly afterwards, maybe once it's processed enough to actually say like. Someone said, when do you say it's good enough? That is so interesting. One of the things I think is like you start to experiment. So like you said, is it good enough? You do your validation tests and stuff like that. I would honestly say that it has to start being tested in real scenarios for you to actually know. So put it into an app, get some beta testers, gradually sort of like span it out to more and more people using it, but give people that honest transparency, like this is kind of in beta, like we are still learning. And also when the budget's almost gone, when you get to that kind of point where you're feeding new data back into it and retraining it, that's always an interesting scenario. But but you are absolutely right. There is also an element of budget. So how often do you want to run? But always remember, use low priority machines. Low priority machines means cheap compute. All of this stuff as well, all that compute is only ever based on when it's running. So I only pay when it's running. It's using something called scalable compute. So when it's not running, that whole cluster of machines just scales down for me. It's so good, because I used to like wake up in the middle of the night in like hot sweats being like, oh my God, I have like 2 GPU machines running and they're not doing anything in my Azure subscription. So that was really, love machine learning compute is the best. Good enough is such a hard question. I know. But yeah, we should ask, everyone should ask that question. That's something you should ask any other machine learning talk you watch. Ask that question as well. When is good enough? I wanted to share some useful information. I've talked about so much. I hope it was interesting. I hope it was useful. Thank you for interacting. It's been really, really cool to chat with you all. Aspect-based sentiment analysis, do go and check out Intel's framework. I've had a really, really good time using it. It was great fun. Also, use the scaffolding code. We use that as an example. It's something to build off. It is not production ready, but it's definitely something to test with and then build out your own scenario and kind of tweak it for you. And then also, if you want to learn more about the Azure Machine Learning Service, there are so many things in there. I hope I've kind of enlightened you, even if it's just a little bit of an overview of what's going on in there, but you can get some information from there. I'll put up some links at the end, so don't worry when we're not live anymore. I just wanted to call out 2 communities that I am absolutely loving to be a part of at the moment. So one of them is something called the Global AI Community. We recently ran this 30-hour stream on April the 8th. I was one of the hosts. I barely got any sleep. It was super exciting. That was I was co-hosting, so I didn't actually stream this whole setup. So this is the first actual stream I've done. But definitely go to live.globalai.community. Find out more about that. Everything we streamed for 30 hours on AI, data science, etc. PyTorch, we had a talk on that. Onyx, we had a talk on that. It's all available on YouTube as videos. So even if you missed it, it's not the end of the world. And then also, I just wanted to call out Ari and my fantastic colleagues are actually able to pull together loads of content, and we've called it AI April. So there is a piece of AI content every single day. Go to aka.ms/AI April, and that will basically give you loads of cool stuff. I have a post coming towards the end of the month. I actually need to finish that. It's a really, really cool place to just keep learning about AI. So highly recommend it. But that's me. I'm 10 minutes over. Apologies, but there was so much to tell you and so much more. Thank you for being so interactive. I've had such a good time. I hope I get to do this again. All right. Thanks so much.